In this lesson, we'll take a look at linear regression with categorical attributes. Of course, we understand that linear regression deals with numerical predictors, but very often we have data sets that have categorical attributes, and we need to be able to perform linear regression in that situation as well. So if you've got linear regression and if you've got categorical attributes and you're doing linear regression, let's take an example file here. So here you've got an example of uh, weights of babies, and here's the weight. That's the target attribute, weight in grams. This is the gestation period of the pregnancy, and this has information about whether or not the mother smoked. And I borrowed the example from this reference. Okay, so of course smoke is a predictor attribute, whether or not the mother smoked, and it's categorical. So this is a good example of a linear regression with a categorical predictor. Okay, so weight is expressed in grams, gestation is expressed in weeks, and smoke is categorical with the two values yes and no. So the question is, does the mother smoking impact the baby's birth weight? Or alternately, if you're given these details, can you predict the baby's weight properly? Okay, so this data is contained in the file called birthsmoke.csv. And first of all, what we want to do is to just take a look at the pairwise scatter plots in this data set. So you can do pairs BS, and it's going to show us all the three attributes here, and it's going to show us the scatter plot, right? So the way to interpret a particular plot, for example, this plot is, well, what is on the x-axis, what is on the y-axis? So here weight, right, when you see the text weight here, that is parallel to the x-axis. So this particular plot has weight on the x-axis and gest on the y-axis. This plot is the exact opposite. It's got gest on the x-axis and weight on the y-axis. Of course, they look quite the same simply because of the pattern. Okay, so this plot, on the other hand, has gestation on the x-axis and smoke on the y-axis, and so on. So that is how you interpret the plot. Okay, so now the point is that if you look at the scatter plots of these, right, you don't very clearly see the role that smoking plays in this whole process. Okay, so for example, you've got smoke and weight. For example, if you see here, well, it looks like for people who smoke and people who don't smoke, this is the set of people who don't smoke, which is 0, that is smoke, which is 1. You're not seeing any very clear pattern from this. Okay, so we obviously would run a regression and see if we can delve deeper into this question. Okay, so here I just wanted to look at the variable smoke. I did strbs $smoke. It tells us that it's a factor with two levels, no and yes, and the values are 1 and 2. And of course, the first particular case, the first row was a yes, the second row was a no, and so on and so on. Okay, of course, we understand that when we have a categorical attribute which is used in a numerical context, then we have to convert the categorical attribute to a numeric attribute by creating dummy variables, and that's what's going to happen in this particular case. You've got weight, gestation, smoke, and smoke has values yes and no, so our data set is going to end up with two additional columns, smoke yes, smoke no. And of course, as we already discussed, we're going to use only one of these two columns because using both of them would be redundant. In fact, in linear regression, if you use both of them, the system is going to promptly tell you that it cannot perform the regression. Okay, so we might have n factor levels, which means that will create n dummy attributes, and we'll use only n minus 1 of these. Okay, now if you recall, we did this in KNN, and we had to be careful and do this manually in KNN. The good news is that with linear regression, you really don't even have to worry about anything. You just indicate that it's a factor, and the system takes care of everything else. You don't even need to worry about converting them to dummy attributes, nothing. LM takes care of everything for us, right? So if something is a factor, if it's already marked as a factor, you have to do nothing. But if it's got numeric values, but you want to make it a factor, then all you have to do is to convert it to a factor and leave it to LM. it'll take care of everything else. So if you do have categorical attributes, but they happen to have numerical values, then you have to explicitly signal that that's a factor, and LM will take care of the rest. So here, for example, you've got region, which has got numeric values, but we want to treat it as a factor. Okay, let's assume that this is categorical. Of course, in this particular case, it is numeric, but we want the system to treat it as categorical. Then here I'm creating a data frame called emp with region as one column and salary as another column. But before we do LM on this, we'll have to do convert factor to a region, convert region to a factor, right? So here we are explicitly telling the system that region, although it's got numeric values, please treat it as a factor. So after this, the system will treat this as a categorical variable and not as a numeric variable. Okay, so let's take a look at the regression. So first of all, we are going to do regress weight as a function of all the remaining two attributes. If you look at the summary of model, then you see this is the overall regression model, right? You're seeing gest, which is the gestation period as a predictor, intercept. And notice that it used only smoke yes, right? Because smoke had yes and no. And when it did the dummy, of course, it would have got two additional columns. But going with the criterion that we want to use only one of them, we want to leave out one of them, it's using only smoke yes. Now in practice, it doesn't matter if you used smoke yes or smoke no. Doesn't really matter in terms of what results you're going to get. The results will still be the same. Okay, so here it says the residual standard error is 115. That means on the average, the model's predictions will be off by 115 grams. Okay, so the name smoke yes was automatically given by the system because the original data frame had just smoke as the name of the column. The values were yes and no. So when it created the dummy, it appended the value of the dummy to the name of the column. Okay, so this regression equation tells us that those coefficients tell us that this is the regression equation. That the weight is minus 2390 plus 143 times the gestation number of weeks minus 245 times smoke yes. Okay, now of course we understand that smoke yes can be 0 or 1. If smoke yes is 0, then the regression equation is simply minus 2390 plus 143 times just. If smoke yes is 1, then 245 will come into the equation. So weight is minus 2390 plus 143 times just minus 245. Okay, so depending on the value of smoke yes, the regression equation takes on this form or this form. Okay, of course, this is just for understanding because we can simply apply that, and if smoke yes is 1, it's going to 245 is going to come into play. If smoke yes is 0, it's not. Okay, so it's not really two different equations. I'm just showing you that it takes on this form depending on the value of smoke yes. Let's visualize the regression. Okay, now because it's regression and because ggplot can directly use, you have the geom smooth function and that can directly show us the linear model. So in this particular case, there's no need for us to even build the regression model. Okay, so we read the data once again, and I'm doing ggplot bs aesthetic gestation weight. Okay, so put gestation on the x-axis, weight on the y-axis. So this time, in this particular case, we are not using the smoke at all. And then we are doing geom point, geom smooth, method equals lm, se equals false. Okay, that is, we don't want the confidence band, and we wanted to use the smooth to use LM, the linear regression. Okay, so that's what the model looks like. Gestation, weight, and the regression equation is the straight line there. and it looks pretty good. It looks like a pretty good fit. Okay, but given the fact that we have not included smoke in our model, we are not able to see here whether smoking has any effect or not. Okay, this model is not telling us because we didn't include it. Of course, once again, with just by using the color attribute, we can make the system plot two different lines for smoking and non-smoking. So here we do that. Color equals smoke, and then geom point, geom smooth, method equals LMSE equals false. Okay, so now you clearly see the two lines. You see, in fact, all the points on top are for smoke equals no, and all the points below for smoke equals yes, right? So you've got the two different lines, and you can clearly see that for a given gestation, smoke equals no has higher birth weight. Okay, so the distance between the two lines, of course, is the coefficient of smoke yes. Okay, so the distance between the two lines is exactly 245 grams. Okay, so that's what you're seeing here. Okay, so you look at this it's about 2400 and that's about 2600. 245 grams is the constant distance between the two lines. So for a given gestation, if a person is a smoker, then it's minus 245 times 245. Person is not a smoker, then the minus term doesn't come into play, and consequently the weight is higher. Okay, so that is how you perform linear regression when you've got one or more categorical attributes. In other words, just mark them as factors and forget about it. Do everything else just like normal. Don't need to worry.